Hi, everyone. We've set up this Being an Engineer podcast as an industry knowledge repository, if you will. We hope it'll be a tool where engineers can learn about and connect with other companies, technologies, people, resources, and opportunities. So make some connections and enjoy the show.
What I found was actually the reverse of that. The more authentic and the more connected you could be to how customers use your product, really the better and more effective you could be at relaying a marketing message.
Hello and welcome to the Being an Engineer podcast. We're speaking with Daniel Lazier today, who is a hands-on problem solver with a background in mechanical engineering. These days, however, Daniel spends his time as product marketing manager at Markforged, where they make industrial strength parts made of nylon, carbon fiber, and metal. Daniel, thanks for joining me on the show today.
Thanks for having me, Aaron.
Can you share what it was that originally prompted you to go into engineering?
You know, I was pretty lucky in that I as a kid, I got exposure to a lot of different kind of extracurricular activities. And the thing that really kind of hooked me from day one, I think this is probably a similar story to a lot of engineers that I was colleagues with, both in college and professional life. But it was really robotics, specifically a feeder into a first team in the form of a Lego robotics team that first gave me the impression like, hey, this is a really cool way to apply math, science, whole slew of other kind of problem solving techniques to something that I could physically hold, see, touch, feel, and ultimately go accomplish goals with that. So went from actually pretty early age in elementary school doing the Lego robotics and doing FIRST robotics, and somewhere in there I got a pretty strong sense of conviction that my future held engineering in some way, shape, or form.
Yeah, my kids do or have done FLL, First Lego League. I think that's what it stands for.
That's what it's called. That's right. It's been so long.
But then in high school, I think it's different, right? Maybe what did you call it? First Robotic League or something like that.
First robotics competition.
Okay.
My high school was not super prominent on the sort of national or global scale, but it was enough to build a robot to go. At the time, the challenge was take these pull inner tubes and pick them up, place them in a certain location. And that was a super neat way to kind of cut your teeth on sort of the multiple collaborative disciplines that it takes to go solve a complex problem.
Yeah. I love learning by doing. Right? I like to say to my team that learning by doing is better. Learning by doing is better than learning about doing, and it's a great opportunity. This FLL, I think, it's really cool that kids have a chance to participate in stuff like that. So you work at Markforged now, and I have to admit, I'm kind of a fanboy of Markforged. I have been for several years now, and I've mentioned the company on this show many times. Probably people are sick of me talking about it, but too bad, because we're going to be talking about Markforged quite a bit today. I've been super excited because I am such a fan of the company, and have been excited to hear a little bit more behind the scenes of what goes on at Markforged and how you're helping engineering teams. So we have two Markforged machines here, and we're using them really, truly all the time. Pretty much every day, both of them are running. There's a material that Markforged makes called Onyx. It's a nylon material with chopped fiber, carbon fiber in it. And those have been like a huge time saver for us and for our customers, especially since a lot of what we do is kind of chunky, blocky, strong parts. We're not using those printers to make like plastic injection molded prototypes. We're using them to make tooling and equipment parts, and it's perfect for that. Maybe you can just take a few minutes and share with the listeners who Markforged is and how you help engineers developing hard goods products.
Yeah, totally. And thank you for that. So, Markforged is really founded on the principle that engineers and designers should really at their fingertips have the capability to make strong functional parts, really just right at the point of need. And that was something that as an engineer, I was like immediately connected to. As someone in a formal role, I definitely needed those kind of parts. So specifically, sort of the Markforged vision is we can reinvent manufacturing by making these devices with these high strength material capabilities, all sort of integrated with a really effective software platform that empowers anybody to make anything anywhere, and thereby sort of reinvent manufacturing and our relationship really with civilization and the planet as a whole.
Where does the name Markforged come from? I've always wondered about that.
Yeah, so our founder, whose name is Greg Mark, the sort of took the last part of his name, Mark, and then forged really just to signify. While our initial product offering was a carbon fiber printer, trying to give some sense that this was something more than just a cheap plastic prototype that many were familiar with in that specific era of the maturity of the additive manufacturing landscape.
Okay. So Markforged has been around for almost a decade now, I think. And I read that the company is approaching 400 employees and 100 million in revenue, which is super impressive. What are some of the growing pains that the company's had to overcome as it's scaled up?
Yeah, I think right now when I look at the state with Markforged, and maybe this isn't completely true to like a real growing pain, but we're finding that like the next hurdle we really have to achieve isn't so much a technology hurdle as much as it is an adoption hurdle. So that's to say, when we go out and meet customers, we often find that the opportunity to sort of reinvent their workflows for the better is often limited by just really people. So like many fields right now, I think we have a bit of a people problem. Where I think we sort of have this need to accelerate adoption at a really rapid rate in order to achieve that sort of next level beyond, how does Markforged become a business that's 1,000 employees, 10,000 employees? I think that's sort of the key to getting to that next phase.
So when you say adoption and people, you're referring more to the people who work at Markforged that are pushing this product out there into the world, as opposed to figuring out how to create the right messaging or provide the right technical solutions for the people out there in the world who will be using the Markforged products.
I should have clarified there. What I was actually referring to is and I think Markforged internal is certainly a component of this, but at a broader level, when we're talking about adoption and people, I really feel like manufacturing. So bigger universe of all manufacturing companies. I just see a trend, an upcoming trend in additive adoption that I think is going to unlock a whole lot of productivity. That's not so much Markforged employees, but more so Markforged users.
Got it. Okay. Can you share one or two unique or particularly interesting or innovative applications that you've been able to help engineering teams with using the Markforged product line?
Sure. Yeah. A couple applications come to mind. One of which I was working with a local high school Formula SAE team, and they were working on specifically this bracket, this suspension bracket. And I actually have a piece of it here somewhere on my desk. I'm not sure if video is going to be a component of what we showcase here, but
it'll just be audio. But you can show me.
Just audio.
I'd love to see it.
Okay, so you can ooh and ah, so the fans know it's cool.
Ooh, ah.
Thank you for that. So this bracket was designed specifically with additive manufacturing in mind, and for the folks who are listening, this bracket has these sort of unique pockets built into it. And some might look at that and say, okay, that's great for lightweighting. Those those pockets actually serve a really specific purpose as it relates to Markforged equipment, where they actually define sort of the pathway where we lay continuous fiber. So I mentioned Markforged sort of built around the vision of making high strength parts. One of our core competencies is infusing continuous strands of fiber into these plastic parts. So now what you end up with is a component that's as strong as metal. And moreover, engineers and designers have an unprecedented level of freedom now to define sort of how this part responds to mechanical stresses. So the really cool part about this thing isn't so much the geometry or that it was 3D printed. The cool thing about it is how it empowered engineers to define how this part would actually perform when it was implemented in practice. So that's one really cool one that stands out. The next one that I'll sort of give as an application. Unfortunately, I can't talk about the customer by name, but this is one case where the innovation wasn't so much the part or how it was made, but more so where it was made. So this was a case where this customer had a bunch of service centers or service depots where they maintained industrial equipment. And they had these things, all over the planet, virtually every continent. I think they were operating in like 30 countries plus, with hundreds of locations. And what they ended up doing with the technology is actually locating a printer, not only at the place where they develop tooling and spare parts, but they also put printers in the locations where those parts were needed. And what they found was that it was actually better for the business to be able to just print the parts at the point of need on demand, as opposed to printing them in one location and shipping them out elsewhere. So they sort of digitized, in that sense, their entire supply chain from top to bottom by simply placing the fabrication equipment, which used to be prohibitive because how hard is it to operate a CNC mill and make those high strength parts in a service center? It's generally not available to those kind of service centers. But now, we've got these printers. You've got one; they're about the size of a microwave. And all you need to run them is a little spool of onyx, and you're good to go. So that comes to mind as one of the more innovative use cases when it comes to our print systems.
Yeah, I can speak to the benefits of that one myself. We have a customer who has a few of these Markforged machines as well, and they engage with us to develop custom equipment for them, and we deliver the equipment turnkey, ready to go. But over time, this has happened. They've had some very minor design changes that they've wanted to implement. And so now they just tell us, okay, we want to change this part a little bit, and we'll update the design, and we'll just send them the file, and they print it out right there and put it into the machine. And it's super easy. It's fast. It's cheap for them, and requires less time on our part. We're always rushing to the next project anyway, so that's helpful. And that's been another really useful application for the machine.
Wow. So just so I understand, you're actually no longer transitioning physical parts between your business and customer's business. You're actually transitioning the digital file. Do I understand that correctly? With
this particular customer, that's
wow.
Right. Yeah.
Cool.
Yeah.
Cool. Yeah, that's super cool.
Yeah. Another thing that's super cool is as I was preparing for this interview, doing some research, I learned about Markforged's new Precise PLA material, which I had not heard of before, and I was super excited to read about this. It looks like it's roughly a third the cost of the onyx material, and I think it was like twice as fast. The print time is about twice as fast as onyx. And just a really attractive solution for teams like mine that are doing a lot of prototype 3D printing. Other than the strength, of course, are there any limitations that we should be aware of? For example, maybe we can't print parts that are quite as big, or maybe the accuracy isn't good, or anything like that comes to mind.
Yeah, not so much in the way of limitations, more just sort of the intent with Precise PLA was really built around giving engineers and designers the capability to quickly and affordably iterate without burning the more valuable onyx to get the part when and where it's needed. And yeah, what we're finding is customers are getting a lot of value out of just not having to worry so much about that. We also find it to be a really nice companion to onyx, just being able to add a splash of color to designs. We've been seeing customers use it just as sort of like a job aid to give operators the ability to basically say, okay, yellow means it's the 10 millimeter insert, red means it's the 12 millimeter insert. So kind of like a color coded pokeyoke there.
Yeah, I love it. What kinds of engineering teams are Markforged machines especially well suited to? And I guess conversely, what kinds of engineering teams are the Markforged machines not a really good fit for?
Yeah, it's interesting. I think we have a reputation for being, a very hardline industrial company. And I hate to call that a fallacy, but I think we probably solve more problems more simply than people give us credit for. And what I mean by that is, I think when people hear continuous fiber reinforcement, high strength, metal strength, industrial parts, I think they often think, wow, that seems super advanced. It might take me a while to learn those capabilities. What we find is it's actually the contrary. There's no sort of nozzle temperatures or extrusion rates or anything like that you have to do any specific training for in order to get the most out of the system. Really, the learning curve has everything to do with application identification, as well as some design strategies. So in that sense, back to your question of, who is this thing for? I would really say anyone who builds physical products generally ought to consider additive manufacturing as a category. And I think within that category, start to identify what kinds of parts, assemblies, and products would benefit from, whether it be high strength in the form of printed continuous fiber, hardness in the form of 3D printed metal, which we haven't talked about a whole lot, but that's also something we do. Or simply, if it's just design validation, what our customers are telling us is, hey, this system that was really well designed for this one thing, which is carbon fiber, also happens to do this concept validation and prototyping material in the form of precise PLA really, really well as well. And that really simplifies my workflow. So kind of a roundabout answer, but I suppose what I'm really saying is Markforged is for everybody.
Yeah, that's a total marketer's answer.
So, yeah, but I mean, to give you a practical example, putting my money where my mouth is, I have my high strength brackets and welding fixtures and all kinds of stuff that I'm flashing in front of the camera, making for decidedly bad radio, I'm sure. But I also have, I'm in the process of building this tractor for my nephew's 4th birthday's coming up. So I'm kind of running the gamut of all kinds of different applications, from sort of tinker maker all the way up to, solving global supply chain problems when I'm working with customers.
Yeah. So something I'm curious about, I'd love to hear your take on this. I have found that the Markforged material or machines are maybe not the best solution for thin-walled parts. So for example, if we're printing like a plastic injection molded part has maybe some fairly organic surfaces, lots of curvature, and is thin wall, 70 thou, 80 thou, something like that. We have other printers that we use for that, SLA printers that seem to be a good solution. The Markforged machines tend to be really, really good when you're printing blocky, chunky, I guess machined type parts. Have you found that to be generally true, or are we just using them in the wrong way? And they'll work great for thin-walled parts as well if we set it up right.
Yeah, so first of all, it bears mentioning I spent my first 3 years at Markforged as an application engineer. So those are exactly the kind of problems I still love to cut my teeth on. So yeah, definitely implore you to send a couple design files over, and we can definitely hash it out. But yeah, I would say to your point, as a category, FFF style printers, which stands for fused filament fabrication, which is the technology Markforged is generally based off of, where I'm drawing plastic from a spool and extruding it out of a hot nozzle, and building the part layer by layer as such. The level of feature detail is definitely predicated on the basis of the diameter of the nozzle. So we find within our category, we generally achieve pretty darn good surface finish and feature detail. I think relative to other additive manufacturing techniques, like you mentioned SLA, stereolithography, where I'm using a laser to effectively polymerize a vat of resin. I generally point customers to that solution if all they're looking for is something that doesn't need to hold up to a whole bunch of wear and tear, but needs that excellent feature detail. So that trade-off between mechanical properties and feature detail, I think it's fair to say there's nothing in the desktop range, at least, that gives you the best of both worlds in that sense. But I think, talking a little bit about like best practices and to our earlier conversation about adoption, one of the things that we generally find for just capturing really good feature detail, I've got again breaking the rules of radio here, but showing you like kind of another little figure here. I got a baby Yoda with really good detail. You can kind of see.
Yeah, that looks like excellent.
The detail on his little shawl there. But one of the little tricks of the trade that I'll pass along to you here is oftentimes just playing around with the orientation and corking stuff over at a 45-degree angle relative to the build plane. Can often yield very, very positive results just by sort of changing the effective resolution at which it's building your part.
Okay, great pro tip. All right. Well, I'll take just a couple second break here and share with the listeners that teampipeline.us is where you can learn more about how we help medical device and other product engineering or manufacturing teams develop turnkey equipment, custom fixtures, and automated machines to characterize, inspect, assemble, manufacture, and perform verification testing on your devices. We're speaking with Daniel Lazier today. So Daniel, you had mentioned earlier that some people might be a little bit afraid of or hesitant to get into this space because they hear continuous fiber, carbon fiber. That's going to be tricky. How do I know what nozzle temperature to use and feed settings and all this stuff? And one thing that I found is that the software that comes with Markforged, which is called Eiger, is super easy to use and makes the whole process really very easy. I think an hour or two of basic training is all anyone needs to really get started on this platform. What are a few highlights that you can share with the listeners about the Eiger software and how it makes printing robust parts so easy?
Yeah, I think the best part of Eiger is something you as a user never ever see, which is just the tens of thousands of hours that our engineering team took to literally and maniacally test the widest range of geometries across the widest set of parameters, from extrusion profiles to temperatures to every setting or parameter that you could imagine going into a successful 3D printed part. I think what a lot of our users tell us is, hey, this is the best quality 3D printer I've ever had. And I never had to change a setting with respect to nozzles or temperatures or extrusion rates. That's sort of, if I were to point to one thing, that's the secret sauce. That would be it. Just the level of detail that went into fine tuning the settings so that you as a user don't have to. And that's sort of the counterpoint to this perception, I think, of approachability with additive manufacturing. I think the next thing I'll point out is just sort of how Eiger manages to balance feature heaviness with ease of use. So what I mean by that is, we have this crazy capability to literally put continuous fiber in any axis on any plane we want. A mechanical engineer generally doesn't think about software when they're thinking about tools, but I think in our consciousness we think, oh man, is this going to take me a year to learn? It took me, I don't know how long to get good at SolidWorks from the day it was introduced to me at college to the time I was using it as a professional engineer. But I think the team has accomplished a really, really neat trick, which is to say, when I want to reinforce this part with continuous fiber, they've intuited some assumptions about how that part is going to be used in the form of how fiber is going to go into this part. So when introducing continuous fiber, you're effectively choosing between two schemes. One is, we call it concentric fiber. I'm tracing the outside of the part and the inside pockets. The other is isotropic, where I'm laying up continuous plies of carbon fiber going at 0 degrees, 45 degrees, 90 degrees, 135 degrees. And that's effectively what laminate sheets are made of, these isotropic planes of fiber. So in that sense, when I use Eiger, I generally find that I'm clicking a couple buttons and then getting a part that is extremely high performance and all built automatically with the kind of settings that I need to accomplish the task at hand. So I think that's sort of category number 2, and to sort of punctuate that, the category number 3, which has less to do about the part and again has more to do with how people use it, but I think just relative to some of the other, zoom out from just 3D printing and just think about other manufacturing equipment I've used. I'll actually point to the example you gave me, which is, you transitioned parts digitally from your environment to your customer's environment. There's companies doing stuff like that actually in the cloud. So, as opposed to like emailing files back and forth using the Eiger platform, to actually send files back and forth. And I think that's really where Eiger stands out above, not just 3D printing equipment, but just manufacturing equipment as a whole, where this all digital approach. I mean, I used to rack my brain and, want to put my fist through my computer screen sometimes working with vendors across a global supply chain, trying to figure out what one specific part I needed. And it was all managed through spreadsheets and bills of materials and all kinds of stuff like that. I think as we get closer and closer to being able to encompass more and more of the manufacturing value chain, the daily life of the engineer is going to get better, largely as a function of how they interact with software in a manufacturing environment. And I think that's sort of where, to me, that third point is probably the most profound in terms of what's great about the software.
Yeah, I have a couple of points to make on that. One is not so much the software, but you mentioned how robust the printer is, and I remember SLA has gotten better for sure over the years, but as soon as maybe 5-6 years ago, we had some SLA printers, and it would drive me crazy the rate at which parts would fail. You'd put a part in at night and come back in the next morning and part failure. And especially with SLA, you've got this goopy resin you have to deal with and clean up and strain out all the little bits that got stuck in there when the print failed. And it was just such a pain, and I hated dealing with that. With the Markforged machines, I can honestly say that we have had very, very few failures. It's such a robust platform, and I've been happily surprised at how consistently it delivers just really great parts with very low maintenance. You just push the easy button, and you get your parts. So that's one thing. The other thing on the software is, because the engineers at Markforged have made the software so easy to use, there are some limitations as far as the degree to which one can customize how the parts are laid out and how the fibers is placed in there. And originally, I thought that might be a drawback, but honestly, I've found that at this point, I don't even care. I don't need to customize it beyond what the software does for you, because it does such a good job.
Yeah, and it's funny, we think about these attributes like customizability, quality, repeatability. I mean, I'll say hand up, as a mechanical engineer, when I used to think about the tools I used to do my job, it probably wasn't that often that I would point to those things as a software thing per se. But really that is what it is. It's code that rests in the background that sort of takes my inputs and makes a part out of those inputs, and it's all driven and it will continue to be increasingly driven by software over time.
Yeah. Yeah. Well, something else that we've been really impressed with on the Markforged machine, the onyx material in particular, is the surface finish, especially on sidewalls. You almost can't even see the layer lines, and it depends a little on what resolution that you're using. But in the right light, it almost looks similar to a textured injection molded part. Other FDM printers that we've used very clearly show the layer lines, and cosmetically, it just doesn't look as good. But the Markforged, the onyx material looks spectacular. And I wondered what is this black magic trickery that Markforged is using to make the surface finish look so good?
Yeah, I mean, it's definitely intentional. There's some work that went into that. I would probably call it a combination of a few different factors. One of which is acute and specific to the materials, and a few of which are general. So the acute one, which we're starting to see more of in the world, has to do with the material formulation itself. So our specific strategy of taking, which we invented, we took nylon pellets and stewed in some chopped carbon fiber, effectively carbon fiber dust. And what did that do for us? What that did was it made it such that when we extruded it out of a nozzle, and it went from, well in excess of 200 Celsius down to room temperature, it made it really stable geometrically across that really, really wide range of materials. So specifically, the characteristic we're interested in there is the coefficient of thermal expansion. So that chopped fiber certainly contributes to a greater stability. But we didn't stop there, right? As you know, we also have a print bed, which is made of a thermally compatible material, which not only contributes to a really high rate of success with printing. I think when we did a Pareto breakdown of like our first prototype 3D printer, we found like 80% of print failures occurred in the first layer. I don't know if your experience is anywhere close to that using other 3D print systems, but that was our experience working with the like other 3D printers and early prototypes. So we found, hey, if you could add some compatibility thermally between the material of the print bed and the material you're printing with, that's going to go a whole lot better for you from a print process perspective. And that also lends to stability from the very base of the print, which the first layer actually has a pretty strong bearing on how the rest of the print comes out. And then the other thing that I'll sort of point out is, for those who haven't seen our systems, there's this huge chunk of aluminum that basically the entire system, the gantry itself, it's all based off of this ultra rigid hunk of aluminum, which wasn't necessarily cheap for us to put into the printer, but we found it was so important to add rigidity to the print platform itself, that it was worthwhile to have this high stiffness gantry system, so that the little micro torques induced when I fire on the belt drive system, that cause other systems to kind of twist like a potato chip, thereby influencing where that bead of plastic is actually going. We found that helps a lot with our overall accuracy, and by extension the print quality. So just when I deposit a bead of plastic on a previous one, how closely did I line those up? The thing that makes these walls look nearly injection molded is the fact that we're very, 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 very precise when we lay that next bead down.
Yeah, that's great. I'm going to take a little departure from Markforged, the company, and talk to you a little bit about marketing right now. You are in marketing. How did you make that transition from being a mechanical design engineer into marketing? What was it that made you think, yeah, I think that would be a cool thing to try out?
Yeah, totally. And hopefully your listeners are at least some of them find something relatable about this journey. But my journey, at least at Markforged, so before coming to Markforged, I was a pretty straight ahead product engineer. I was developing little GPS sensors for a company that eventually got sold to Ring, which was bought by Amazon. Um, so that was a point where I was first exposed to 3D printing, primarily in a prototyping capacity, and I sort of knew at that point that that's where I wanted to take my career next. Um, so what I ended up finding was this awesome opportunity to come on at Markforged as an application engineer, which is sort of like that first step going from like becoming like I almost joke it's like going from like an inside cat to an outside cat, where I start to get to see a whole lot of cases of customers actually using the technology. Um, I still maintain that's probably about the most fun you could have with a mechanical engineering degree, being an application engineer at a 3D printing company, because what that really was like a consistently revolving game of how it's made. I don't know if you ever watched that show, How It's Made, but I used
Oh
to
yeah,
just like,
yeah.
eyes glued to the TV for 3 hours straight watching that stuff. Um, so that's kind of what my life was like. And that role was really specifically, you asked, how did that transition to marketing? Um, it was in some sense kind of like a sales role, but in a really authentic way where I'm not trying to sell you equipment you don't need. It's very, I come with a very strong sense of conviction that this is a better way to make your product. And luckily, when I can take this part, say, hey, you were making this thing for $1,500. I just printed it for 50. And it takes less time to build. It's safer for your employees. That was a really fun way to connect with customers, and I've made lifelong friends with some of those customers as a result. So as the stakes got sort of bigger and bigger, the company got higher profile, and we started working with sort of bigger customers with larger implementation needs. The role sort of evolved into really sort of like a presentation kind of role where we were talking to executives at large businesses saying, hey, here's my recommendation for how you should implement our technology. And as much as I resisted it, my mentors, my superiors, my bosses were all telling me like, hey dude, that's what you're doing there is actually marketing. And I looked at that and said, oh, that's not what I want to do. And I think that was sort of built on a fallacy that marketing was intentionally deceptive or something disconnected from how customers actually use our technology. What I found was actually the reverse of that to be true, which is like the more authentic and the more connected you could be to how customers use your product, really the better and more effective you could be at relaying a marketing message where the technical attributes we were just talking about the system are all true, and they all relate to why someone ought to consider buying your equipment. So I think it took me a while, really, I must admit, to sort of release myself from this constraint that we shouldn't boast so much about our systems, and how great we are, and actually achieve a level of comfort doing that. But I think once I kind of got over that hurdle, it really became a really cool way to extend my career into more of a strategic role that had less to do with one by one educating customers on what we do great, and sort of using a megaphone to do that at a much broader scale. So in that sense, I think it's been a super, super cool journey at Markforged. Certainly one I did not intend or predict, but oftentimes the best opportunities sort of come that way.
Very cool. For engineers out there who might be thinking to themselves right now, that sounds kind of fun, this whole marketing thing. I might like to dip my toe on the dark side myself and see what I can make of this. What kind of considerations should they keep in mind when trying to decide one way or the other?
I'll think on that, and I'll stall a little bit by saying I think the journey that I took was really the journey that I needed to convince myself and sort of grow this. I mentioned this like sense of conviction I had that we were selling customers the right product at the right time, and we were doing all of that authentically. So I think there's like internal factors and externalities. So I mean, hopefully we're all working for companies that make our customers better off when we're done doing business. But I think that's certainly a litmus test that I think engineers specifically would be miserable if they were trying to market in a role if that weren't true. If that makes sense. I think the other factor one ought to consider, and I think we oftentimes sell ourselves short as mechanical engineers in our ability to present and communicate and sort of articulate ideas to a broader set of people, not just other engineers. What I find is there's a very healthy subset of engineers that are actually excellent communicators, and I think those people in particular ought to really think about how they could take what they do and sort of in my field. I mentioned at the very beginning of this call, at the beginning of this podcast, our mandate as a company really ought to be how do we accelerate adoption? And really, if I trace my career from the start of Markforged to where I'm at now, which has been about a 5-year journey, I really feel like we're doing more and more of that the further I go down. And now in this marketing role, if I think about every activity I do, every piece of content I make, every thing I do, like today, we're on this podcast talking about it. Really, I think every day it's sort of advancing the ball, getting better and better at accelerating adoption. And I think there's something kind of neat about that.
Yeah, for sure. Well, just one or two more questions, and then we'll wrap up here. What's in store for the future of Markforged? What can we look forward to in the next 2 to 3 years and beyond?
Yeah, I think there's so much exciting stuff that has happened in the last year, and I think in some ways the past can in some ways predict the present. But I would expect to see a whole lot more in the way of how software is used, and part of that is likely to come from advancements from companies like Markforged and some of our partners, companies we partnered with. We just acquired a company called Teton Simulation, which sort of specializes in modeling how 3D printed parts are going to respond to stresses. That's going to be a great partner technology that again will be one more step toward accelerating adoption in some more scrutinized areas like aerospace. But yeah, I think just sort of like continually advancing the ball with respect to software. I think just the kind of things that already make the system great, the availability of the materials and that solve a bunch of different problems, the quality, the kind of optionality you have in Eiger. I would expect in the next 2-3 years, all of those things to continually improve. We release updates to our systems you're a user, you probably print more than I do, but I find practically every time I log into Eiger, there's a new update waiting for me to try. And I think that's sort of the exciting thing that can't quite put your finger on it what exactly that is, but we know it's gonna make your printing process a whole lot smoother.
That's another great thing about Eiger is it's cloud-based software. So there's nothing to install and update and update and update. It's all just updated every time you go in automatically, which has been super nice and helpful. Yeah. Totally. All right. Well, Daniel, thank you so much for your time today. How can people get in touch with you? So again, I work at Markforged, and we love talking to prospects and customers. We have a whole lot of forums and chats and all kinds of things you can reach out for us at the website. I sit on the marketing team, so messages that go to marketing@markforged.com, I generally get a look at those. So if you have questions or want to reference this podcast and say, hey, I got a question about something Daniel said on the podcast, that would be a great avenue to do so. Terrific. Great. Well, anything else that we should cover before we end?
No, it's a pleasure talking to you and learn a little bit more about what you do with our printers, and super fun talking about it.
Likewise. I love talking about manufacturing.
Awesome.
All right, Daniel. Well, thanks so much. Really appreciate your time.
All right. Thanks, Aaron. Have a great day.
I'm Aaron Monker, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.